So next question, I'll move on to Sharath for this. So we've discussed about these agglomerative and k-means and DBSCAN. These are the three main things that at least our participants have been explained about. Also because these are the ones that are most popularly used. So can you give a little more depth into how these differ from each other? All these things.
Okay, all right. So when we talk about these three algorithms, right, the most important algorithms that are typically used. The first one I would like to talk about is agglomerative clustering. For a simple fact that it is very easy to explain, it gives you a natural flow. Right, this algorithm is basically allowing us to visually inspect how the groupings can be formed. But the drawback here is it can't really work with outliers. Right? If you have outliers, then the entire flow, the hierarchy that we're constructing is getting haywire. And as I've already mentioned, it is computationally expensive. Another point is if you already have a predetermined number of clusters in mind, then probably that number of clusters probably may not be possible in agglomerative clustering. You may not get that kind of a grouping. So you'll have to resort to the dendrogram and then decide how many clusters would be appropriate on the data. So you'll not have control for you. You'll have to rely on the algorithm and then decide. Whereas if you talk about k-means clustering, the advantage is that it is computationally much faster, inexpensive. You'll be doing less number of computations. And coming to the disadvantages, the challenge is to identifying the right k value, which basically is nothing but the number of clusters. Of course, we will have something called as algo curves, and then we will also have metrics which are used to measure the intra-cluster variance and inter-cluster variance. But still, we call it as within sum of squares. But what happens is the decision again over the number of clusters may be a little bit of ambiguous. You may not always get a perfect bend, elbow bend in your graph. So you probably will have to again, do a trial and error between the multiple options that you may come across, and then you'll have to decide what is the best one. The other disadvantage with k-means is that it's a non-deterministic algorithm, though it is very fast compared to agglomerative clustering while in terms of computations. But the problem is the responses that we are getting, right, the final results that we get may not be stably given. It may not be the exact one. So this is basically the challenge with respect to the k-means clustering. Now, another technique that we spoke about is the DBSCAN clustering. The first advantage is it is very fast compared to k-means as well. Right? You can do a benchmarking. A lot of benchmarking has been done. DBSCAN is very fast. And the other advantage is that it is robust of outliers. It is very, very much resistant to outliers. It doesn't get impacted with outliers. We are basically looking at the density. As the name says, it looks into the area, which is defined by a metric called radius. Right? We basically have a EPS. EPS is basically the radius. And within that radius, if you have minimum number of data points that we upfront define, then it becomes a cluster. So the advantage is that it is robust of outliers. The performance is much faster, right? So that is the advantage. But the disadvantage on the other side with respect to DBSCAN is that if you don't choose the right radius, depending on your business requirements, depending on the data and the values that your data carries, if you don't choose the right radius and the minimum number of points, because these are the two parameters which DBSCAN relies on. If you don't choose, then your entire clustering is going to give you a wrong interpretation, wrong results completely. Right? So that is one of the problems that we will have with the DBSCAN approach. It also has another challenge that if you have too much of varied data, right, sparse data, then you cannot get those clusters. Right? It is basically dense area that it is trying to capture, and if your data itself is very sparsely spaced, you cannot get the clusters appropriately. Right? So these are the high-level comparison points between the three popular techniques that we have or we have been using. And as you can see, the mind map right on the screen, Mr. Nitin is showing. The mind map is
the
pointing
reason,
out.
sorry to interrupt you. The reason why I immediately got excited and showed you the mind map is, at least this is something that participants from 360 would be aware of. We've been emphasizing that you please look into the mind map. It is like a complete, you can eat nutritious food. All right, having green vegetables, you can have. That is a good thing. Eat nutritious food. Eat everything, greens, carrots, proteins, carbo, everything. Or you can have a pill. All right, you can have a multivitamin pill. So our mind map is like that multivitamin pill. In case you are missing out on some nutrients or some things, you can always, this mind map alone is not enough. You have to learn everything. But everything is made into a concise, and that squeezed out juice essence of it is available here. So that is why, as a quick reference, eventually you should be able to memorize in your mind that hierarchical clustering, and then after hierarchical clustering there is partition, after partition there is density, after density there are three more things which I have not spent too much time, but yeah, I remember there were at least four more. At least to that level you should be able to recollect, and to certain level of drill down we have explained all these things in our mind map. So that is why, to have a visual association with what Sharath is saying, I decided to open this mind map and let you have a look at it. Yeah, sorry, Sharath. I wanted to explain the
Thank you
reason
so
of
much
that.
to share that. Thank you so much to share that on the screen so that our viewers can actually correlate to what we are speaking here. And to access this mind map, our students already know it's available on the
Yeah,
website.
I'll have it shared in this thing. In this thing, I think many of you may not be our students, so you'll be getting this in the YouTube chat as well. All right. Okay. So thank you, Sharath. Yeah, it's quite a comprehensive and a detailed explanation about the differences, the uses of the three predominant, clustering methods that we use: hierarchical, non-hierarchical, and density-based. Within density-based, of course, the DBSCAN. Of course, there is something called as optics as well. Pretty similar, but operates on a slightly different level. So if you know DBSCAN, it is pretty much good enough. The next question is with reference to the understanding of the choice of the K value in partition-based, specifically non-hierarchical K-means clustering. So we have something called as the scree plot, and we choose the elbow curve. So almost everybody whom I have interviewed are aware of what the elbow curve is. This is an elbow curve. In that elbow curve, the place of the elbow is the K value that we choose. What does that elbow actually signify? What does it tell you? What are the inferences or insights that you can take? And why does it show an elbow at that particular point? If you could, explain a little bit on that, that will be great. Maybe if you can illustrate with the drawing, if possible, or whatever. Yeah, Sharath.
Yeah, thank you. Sure. So the decision, right? If you look at the approaches, the agglomerative clustering, that is hierarchical clustering, and non-hierarchical clustering, the specific model that we are speaking about is K-means. The approach itself says that in K-means, in order to the algorithm to kickstart its work, it needs to be specified on how many groups it has to make on the data. So as an algorithm input, right, the parameter, we are saying you have to start splitting your data into these many groups. But saying this, The objective of clustering itself is to ensure that we get homogeneous pairs of groups, right? Homogeneity. I need more consistency in my data, in my group. That consistency would allow me to extract meaningful information for that particular group. So we are speaking about that consistency here. Now, the elbow curve is, the scree plot basically captures the within sum of squares. In Python, we call it as inertia. That's how the k-means clustering is going to return us the value. This is basically the squared distances of each record within that cluster to its center, cluster center. Now, when you talk about minimizing the variance or improving the homogeneity, the data points should be close to each other. That means the overall distances of the data points from the core center of that cluster should be less. So if I split my data into two clusters, am I able to get that homogeneity? Or do I have to split it into three clusters to improve that homogeneity to a drastic value, right? Drastic decrease has to be there. So the significance is that if you look at the elbow here, right, I'll speak about this. I'm starting here. This is the dip, right? If I try to lower my camera. So if I put my elbow like this, from here, this is my inertia when I say k equal to 2. But when I say k equal to 3, there's sudden decrease in that inertia, right? But after that, even though I increase the number of clusters, the inertia is more stable. It is not decreasing. That means the homogeneity is not improving, or in other terms, the variation in the data is not becoming better. So it would be an ideal point to choose this value as k, hence the name elbow curve, right? And you'll be able to choose the number of resources, and you can come up with different strategies and all that, depending on that k value that gives you the best inertia value, which is also called as within sum of squares. I would also like to add a point that the scree plot or elbow curve that is popularly known is trying to represent the inertia value in a visualization. Now, this can also be done in different ways. In Python, we also have something called as knee locator. That is another algorithm you can use for the right identification of the best value of k.
Thank you, Sharath.